So for that design you have to go back to the main menu. Modeling కి మళ్ళీ వెళ్ళిపోతారు. Bending and shear force diagrams అన్ని చూసిన తర్వాత you will go back to the main window, and here you have an option called design. ఇక్కడ మీకు ఆప్షన్ కనిపిస్తుంది డిజైన్ అని.
Yes, sir. Condition.
ఓకే, సో ఆ ఆప్షన్ మీద మనం క్లిక్ చేయాలి. ఆ డిజైన్ ఆప్షన్ మీద క్లిక్ చేస్తే యూ విల్ బి ఏబుల్ టు సీ ఆల్ ది సబ్ ట్యాబ్స్. ఇక్కడ ఇవన్నీ మారిపోతున్నాయి, ఇవన్నీ సబ్ ట్యాబ్స్. సో ఇన్ దిస్ యూ హ్యావ్ కాంక్రీట్ డిజైన్ అని ఉంటుంది చూడండి, కాంక్రీట్ డిజైన్
Concrete, sir.
and steel, and also steel design, concrete design and steel design. So concrete design is for RCC and steel design is for steel. Okay, so ఇక్కడ మీరు కాంక్రీట్ మీద క్లిక్ చేస్తే, if you click on concrete, automatically this side screen will change. ఇక్కడ ఈ screen అనేది వస్తుంది. From this you have to select the code book. Code book ఇక్కడ select చేయాలి. You have to select the code over here. So here as per the Indian standard, what is the code for the concrete? What is the code for the concrete? Can anyone say what is the code for the concrete design? It is IS 456 for concrete, basic code currently. So you have to click on this concrete code IS 456. As per this code, if you click on this one, you will have some more parameters. Ikkada meer chuste you have these three commands: select parameters, define parameters, and commands. Okay, so in this you have to click on define parameters. Define parameters ante ఏంటి ఇవ్వాలనేది. So if you click on this define parameters, you will have all the important parameters as per IS 456. It will be there. So we are not going to select all of this. We are not going to give all these. By default, the software will take. We are going to give only the grade of concrete and grade of steel over here. So that is the important point. So whenever you go for the design of any structure, first one is grade of concrete. Grade of concrete ఎంత తీసుకుందాం తెలుసా? గ్రేడ్ ఆఫ్ కాంక్రీట్ అంటే ఏంటో? Hello?
Mixed proportion.
Mixed proportion, yes. So I am taking M25 grade of concrete. Then grade of steel. Grade of steel. Generally, there are three different types of grade of steels that will be used in the design. That is, first one is mild steel. Then you have Fe 415 steel and Fe 500 steel. That is high strength steels. Generally, 415 grade uses 415 Newton per meter. Okay, and this one also. So this is the grade of steel that we have to use. So if you see that there will be point over here, that is FC and you have to click on that FC value. This is the point that you have to select. So if you click on this one, you will it will ask you compressive strength of concrete. So what is the compressive strength of concrete that we have selected? M25. M25 units are what?
Newton per mm square.
M25 is the Newton per mm square. Newton per mm square. So to convert it to kilonewton per meter square, 25 you have to multiply into 25 into to convert into mm to meters. You have to multiply with 10 power 6. So that is 3.
6, 10 power 6.
3. And you should divide by to convert it to kilonewton. It is in Newton. To convert to kilonewton divided by 1000. So it is going to become
10 to the power of
25,000
1000
kilonewton per meter
newton
square.
per meter square.
25,000 kilonewton per meter square. So here you have to type over here. You have to type in this box 25,000. Okay. Once you type over there and click on the add button over here. Okay. Once you click on the add button over there, it will add out. It will create a box over here and it will be added over here. So I'm clicking add over here. So you can see that it is creating
FC 25,000.
this one. This file has been created, and there is a question mark over here. It is saying
MR, sir.
it is asking, question mark means it is asking to which members I should
To
assign
select.
in
Yes, sir.
M25. Okay, so you have to assign to which member it is asking. So here M25 is for the entire structure.
Enter.
So you can select the entire structure like this, and select the M25 grade of concrete, select the entire structure, and here you have assign method, assign to the selected beams option. Click on that, and below that you also have assign button. So after that you click on this assign. It will ask the assignment method you have chosen is assigned to selected geometry. Do you want to proceed? Click on yes. So the entire, all the columns and beams got assigned with M25 grade of concrete. So the structure will be designed for the M25 grade of concrete. Then similarly, we have to assign the, after assigning the concrete, we also have to assign the grade of steel. So again, go to the
Steel.
defined parameters, and in defined parameters, you have over here Fy main and Fy secondary. So secondary is for the stirrups distribution steel. Main reinforcement is what the load will be directly acting. So the once you click on this Fy main, it will ask the yield strength of main reinforcement steel. It is going to ask yield strength for main reinforcement steel. So by default, it is giving us 413688. But if I share you our material, we have taken this one grade of steel as 415. So you have to convert into kilonewton per meter square.
Meter square.
So
Into 10 to the power of 3.
if you convert that 415 into, to convert into mm to meter square, you have to multiply with 10 power 6 on the numerator, and in denominator, to convert from Newton to kilonewton, you have to divide by 1000. So finally, you'll be left with 4,000 kilonewton meter square.
Kilonewton meter.
Kilonewton per meter square. This is what you will get. So go here and type 415000 and just click on add button over here. If you click on the add button over here, this value will reflect over here. This value will reflect 415000 will reflect over here. So I'm adding this one. Click on that. So automatically you can see that and if you add and close, you can see that there is here Fy main 415000 is been added. Similarly, for the secondary reinforcement also you have to add. So click on the secondary Fy secondary. Click on Fy secondary, and also you type it over here 415000. If you type it and click on add and close, you can see there the loads have been the stresses, the material properties have been added, this one and this one. So this Fy main is for all the members, in the structure, and Fy secondary is also for all the members in the structure. So I have to select the entire structure, uh, select Fy main 415000 and click on assign to the selected beam. Click on this assign to the selected beam and click on assign and say yes. Sorry, I have to select the entire members and click on this. So automatically it will be assigned. Similarly for this FY secondary also, you have to select all the members and click on assign. So I have added grade of concrete and a grade of steel. Again, if you go to the defined parameters, there will be another important one is that track is over here. Track. So this track, if you click on the track, you will get an option. You are getting three options. You can see over here. There are three options. There are three options available over here. So these three options actually track is something that beam and column design only minimum details printed. You can see that it is saying printed. It is saying that the calculation will be done for this one and you have it will be printed automatically. That means there is an option over here. After doing analysis part, you can see I'm drawing an arrow mark over here. Here, can you see that arrow mark?
Yes.
See this one.
Yes, sir. Yes, sir.
So this arrow mark where the whatever report that you are selecting, it is going to print over here. The report loki velpotundi. So after running this analysis and click on this icon, you can see the entire report of each individual beams. ఇక్కడ ఏవైతే beams ఉన్నాయో అవన్నీ beams and columns అవన్నీ ఇక్కడ కనిపిస్తాయి అన్నమాట. ఈ రిపోర్ట్ లో కనిపిస్తుంది. Okay. So there are three levels: minimum details, intermediate level, and steel required. The beam design track steel required at 1/12 section, column D. So these are little bit advancement. అంటే starting first one ఏం చెప్తుందంటే percentage of steel ఎంతనే చెప్తుంది. సెకండ్ ఆప్షన్ సెలెక్ట్ చేస్తారనుకోండి, ఇక్కడ సెకండ్ ఆప్షన్ లిటిల్ బిట్ ఇంటర్మీడియట్ కొద్దిగా క్యాల్కులేషన్ చూపిస్తుంది, ఎక్కడ మాక్సిమం వచ్చింది, ఎక్కడ మినిమం వచ్చింది, అండ్ వాట్ ఈస్ ద పర్సంటేజ్ ఆఫ్ స్టీల్ అని చూపిస్తుంది. Okay, like this. If you select the third option, if you select, is going to show the minimum details that are required and also the maximum details. Inka ekkada design chesindi at different levels, it is going to show. So if you select this first option, the the output will be only limited restrictions are there. If you select two, there will be little bit కొద్దిగా ఎక్కువ వస్తుంది రిజల్ట్స్. థర్డ్కి వెళ్ళేసరికి కొద్దిగా అడ్వాన్స్ వస్తాయి, అంటే డీటెయిల్ గా క్యాల్కులేషన్ విల్ బి ఇన్ డీటెయిల్. At every 1/12 you can get the details. So that is the thing. So you can select option 1 and you can proceed with that option. So I'm selecting 1 and click on add. So if you click on add, it will reflect. Click on add and close, it will reflect over here. So track 0. What is that 0? 0 అని ఎందుకు వచ్చింది అక్కడ? 0 అంటే this option. If I'll go back to the same point and go to the track over here. 0 is the symbol that it is indicating over here. ఇక్కడ 0 అని ఉన్నది చూసారా? ఈ 0 అది. ఒకవేళ 1 మీద క్లిక్ చేస్తాను అనుకోండి, 1 మీద క్లిక్ చేస్తే and click on add, it will show the track 1. అంటే track 1 అంటే మీకు ఆ నెంబర్ ఆఫ్ పేజెస్ కానీ నెంబర్ ఆఫ్ లైన్స్ కానీ కొద్దిగా పెరుగుతాయి. track 2 అంటే ఇంకొద్దిగా ఎక్కువ పెరుగుతుంది. So I'm deleting track 1 and then select the track 1 and select the track 0, select the entire structure and click on assign and say yes. Click on assign and say yes. Then the entire beam will be so the entire structure will be assigned with the track. So this is the next point. Then next important point is our commands. ఇక్కడ కమాండ్స్ అనే ఆప్షన్ ఉంటుంది. ఇప్పుడు ఏంటంటే మెటీరియల్స్ ఇచ్చాం మనం, ఇక్కడ మెటీరియల్స్ ఇచ్చాం అంటే గ్రేడ్ ఆఫ్ కాంక్రీట్ ఎంత, గ్రేడ్ ఆఫ్ స్టీల్ ఎంత, అండ్ మీకు రిజల్ట్స్ ఏం కావాలనేది ఇచ్చాం. నౌ యూ హ్యావ్ టు గివ్ ది కమాండ్స్ లైక్ కాలమ్ డిజైన్ చేయాలా, బీమ్ డిజైన్ చేయాలా, స్లాబ్ డిజైన్ చేయాలా అనేది కమాండ్స్ ఉంటాయి. సో ఫర్ దట్ కమాండ్స్ యూ హ్యావ్ టు గో, ఫర్ దట్ థింగ్ యూ హ్యావ్ టు గో టు దిస్ కమాండ్స్. So I am going into that commands. Click on the commands button over there, and now you can see that there are design beam, design column, design slab elements, and takeoff. Takeoff is a very good command, a very good point to add, because if you click on takeoff, it will give the quantity of concrete and quantity of steel for this entire structure. ఈ మొత్తం స్ట్రక్చర్ కి ఎంత కాంక్రీట్ పడింది, ఎంత కాంక్రీట్ ఆఫ్ how much is the quantity of concrete that is required and how much is the quantity of steel that is required will be detailedly given here in if you give this command takeoff. So I am clicking on this add beam command and I have to click on this add option. So if I click on this add option, automatically my it will reflect over here. If I click on this add, it will reflect after the track. Okay, so now if I click on add over here, now you can see and close it. You can see that the design beam has been added, right? And similarly click on the commands and there is an option called design column. So if you click on this design column and click on add, it will be reflected over here. And I am not going to select the design slab and element because it is not required for this model. So I am going to next select takeoff. So it is clearly giving over here. If I select design of beams, you can see over here design beams for flexure, shear, and torsion. It's going to do as per IS 456 code book. And similarly, if I click on this design of columns, it is showing their design of columns for axial load plus biaxial bending. So what is this biaxial bending? Biaxial bending ante enti? Can anyone say what is this biaxial bending? So biaxial bending means bi means what? Two. Mono means single. Right?
Single.
So if I
Two axial loads.
two axial loads, if you have the column like this, if your column is like this, the biaxial moment, that is it can bend in this direction, the column can bend in this direction, the column can bend in this direction, so it is biaxial. Uniaxial means what? Uniaxial means if your column is like this, only one side you have the moment, only one side you have the moment. This is biaxial. You have mx and also mz. So here uniaxial means we are having only mx. Or sometimes uniaxial means only mz also will be there, like this. Like this, only on this side only the bending will be there. This is mz. This is uniaxial. So this is the biaxial moment. So if there is, sometimes there will not be any loading also. moments also. When there is no loading, then it is called as actual load. Exactly at the particular point, the load will be acting. So it is called as point load, actual load. Then write it as point load or actual load. Actual load. Okay, so these are different types. మనం జనరల్ గా టెక్స్ట్ బుక్ లో నేర్చుకున్నది దిస్ యాక్సియల్ లోడ్స్ మనం నేర్చుకుంటాం. ఈ బయాక్సియల్ మూమెంట్స్ అండ్ యూనియాక్సియల్ మూమెంట్స్ ఆల్సో we have to check. So this the load will be acting, these diagrams you can see the load will be acting on both the faces of the column, and on this side only on one face of the column, and in this diagram also one face of the column. Here there is no moments in both the directions, only actual load P ఒకటే ఉంటుంది, డైరెక్ట్ గా పాయింట్ లోడ్ యాక్ట్ చేస్తుంది. So these are the different types of loadings that you can see in the uh, individual columns. So what it is saying that here design of columns for axial load plus biaxial bending. So it is going to design, check the both the loads, and it is going to design. Okay, so I have to click on add and click on close. You have to click on close. So automatically, if you click on close, it is going to reflect over here. You can see that design of columns and design of beams will be added. And I forgot to click on take off. So if you
Take off.
click on take off, I told you that it's going to print the concrete and steel quantity. But let me do this. I'll show you. After that, I'm going to assign. So now what I'll do is that I'm going to assign the beams. Select the design beams command, and select, you have an option over here, select beams parallel to x-axis, select beams parallel to z-axis, and click on assign. Okay, then you have design of columns. So go to select beams parallel to y-axis and assign this command. Right, so this is how you have to do the procedure for the design. These are the important points that you have to select for the design of the concrete. So if you have any doubts, you can revise this video and you can check how to assign these commands once again. Right, after assigning these commands, you should get a tick mark over here. You can see that you are getting a green color tick mark over here.
Green tick mark. Yes,
Yeah,
sir.
that means you have assigned all the commands. So once you have completed assigning these commands, you have to go for the design procedure. So for the design procedure, you have an option of here, concrete. Uh, you can directly go to the analysis option over here and click on the run analysis. So go to analysis, click on run analysis. It's going to say click on this. So it has now completed the design also. So here the design, how much time did it take the software? Not even. It is highly, you have to catch this point very carefully. You can see that it has completed the entire design within less than 1 second, not even 1 minute, 1 second. So you can just imagine how quickly you can complete your project works if you become a structural engineer. So now you have an option over here, stay in the modeling mode, go to the post-processing mode. So in the post-processing, you can see the bending moment, shear force, deflection, and all those values. Then go to the view output file. If you click on this view output file, that is, I told you, know, there will be an option over here, report option over here. This one. Can you see
Yes, sir. Yes, sir.
this option? Right, so that particular option, if you click, then you will go to the view output file. So if you want to see the bending moment, shear forces, and deflections, then you can go to the post processing option. You can go to this post processing option, or if you want to stay in the modeling zone, you can stay in the modeling zone. Right, so what I'll do is that I'll
Yes,
go
sir.
to the view output file. I'll click on this view output file. I'll click on this view output file and click on done. So once you click on the this is the software that window. If you see in this window, you can see the entire program that has been written by the software. Idanta background lo run out. So it is going to show over here this entire part up to the line 65. Up to line 65, it is showing the point. Okay, so this is all the program, nothing to do with this. After the program, then the problem statistics, it is going to show the results. And these are all the important results that you can click. And here you have an option called results. Left side bottom you have option called results, right? So if you click on that result button, you will get this screen over here. These different points will be created. So here you have to select uh, beams. It will directly go to that particular page. And if you click on column, it will go to the column design. So what I'll do is that I'll click on beams. So if I click on beams over here, it is going to show the beam design details. So here clearly it is written over here IS 456 2000 beam design results. As per IS 456, the beam design results have been posted over here. And it is showing beam number 19. You can see this beam number 19 design results. So for that particular beam, and the section size is there, the clear cover the software is taken, the length of the member is 3000 mm, that is 3 meters, and the reinforcement that is required. You can see the top reinforcement and the bottom reinforcement that are there, right? So you should know what is this top reinforcement and bottom reinforcement, and the other. So the top reinforcement is, if I draw the section over here like this, the top reinforcement is over here. You can provide the steel over here like this, and the bottom reinforcement is like this. See, the top reinforcement is given, that is 180. You can see over here 180 183.92 square mm square. You can say that it is square. At a distance of 0, at a distance of 0, at a distance of 750 at a distance of 1.5. See, at a distance of 1.5 means this beam length is there, no? Along this
Yes, sir.
along this is the beam length, right? Along this is the beam length, right? uh,
Yes, sir.
this is your beam, right? If I draw it like this is your beam, right? So he's saying that if I this is your beam length of 3 meters. So at a distance of at a distance at zero distance, the reinforcement is one uh, 183. This point 183. So here at this phase the reinforcement is 183, and at the middle phase it is not required. That is 0 and 0 and 0, and again at the end, it is 141.33. The reinforcement is over there, and at the bottom you have 127 and 127. So here you should have 127 and 127 at the middle at a distance of 1.5. This is your distance of 1.5. So like this, for each and every beam, it is going to show the calculation. You can see the calculation for the next beam also. It is going to show, and also the stirrups over there. Let me clear everything. And also the stirrup spacing also is there over here. And you can see over here the shear shear force that is required, shear force that you're getting, and the spacing of here, that is 110 mm center to center, two legged 11 uh, 0 mm center to center. That is the stirrups that you have to provide right around the right around this particular main rods like this. Okay. These stirrups will be placed throughout the length, along the length of the beam. The stirrups from here to here, it is going to be provided at a distance of 110 mm. So at every 110 interval, there will be another stirrup over here like this, everywhere in the beam, and the main rods will be there in between these uh, stirrups. Okay. So that is about beam number 19. Now, if you see, uh, the next is beam number 20. Beam number 20. The same procedure will be there. So it is going to be, you can see that beam number 20. So if you click on go down like that, for every beam, the results will be posted over here for every beam, right? You have so many beams in this structure. So if you go to the structure, main structure, this, you have many beams, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 beams in one floor. So 12 into 1, 2, 3 floors, 12 into 3, that is total 36 beams you are having. So the results of 36 beams will be shown in this report, right? However,
Yes, sir.
the beam number is different. It is starting from 19. Okay. So like this, if you go down, then you have columns. So directly, if you want to go to the columns, click on this columns button. On the right side, there is a columns option. Click on that columns button. You can go to the column design. Now this is the column design. Now you can see that IS 456 2000 column design results. So for the column number 51 design results. So this is the step from here to here, from this column phase to this phase. Kanishi idanta. This is your column design. You can see that the length of the column is 3 meters. The section size is of here. The cover by default, the software is taken as 40 mm, and the required steel area is 147, and the concrete area is this much. So it is saying provide 8 numbers of 12 dia. So 12 dia rods, so 8 provide share. That will give you an area of 904 mm square. Then tie reinforcement, that is the stirrups that you have to provide at a spacing of 150. And these are the calculations, manual calculations that it has done. So this is what is important for us. E point up to the ties steel, it is very important for you to provide in the at the site, right? So this is about the column reinforcement details. So if you go down like this, you will see all the column. How many columns you have, those many column details will be provided in this report. But at the end, I told you, you will be also getting the what is the total quantity of steel and concrete. What is the total quantity of steel and concrete? that it is not shown over here. ఇక్కడ because we have not given the command takeoff, right? So
Take
next,
off.
yes, what I'll do is that I will give that command takeoff. Now we'll see at the end whether we are going to get the results or not. So this is the end. I came to the last page. You can see over here my uh, you can see over here on the right side bottom, I have scrolled down completely. So let me close this one and go back to the Staad file. Here, go to the concrete and the commands I told you. In the commands, you have the takeoff command. Click on this command, and there you have the takeoff. And see here, it is written clearly uh, that print the total volume of concrete and weight of the steel reinforcement for the beams and column and elements design. So it is going to show the values, right? So if I click on this take off, add and close, uh, take off, click on add and close, it is going to ask directly, automatically it is assigned. See this one, concrete takeoff. Automatically it will be assigned, no need to assign it to the structure again, right? So now let us run the model once again, right? Click on done, and then go to the report over here. I told you there is a report option over here, right, on the top. So click on that one, and you can see that you have result option over here. Go to the result option, and then you can directly click on the columns over here.
Window కనిపించట్లేదు సార్ అది.
Okay,
Report.
yeah, this one, right? You can click on the result option. It will be initially it will be like this. Initially it will be like this. You have to click on this result button over here, and then if you click on this, you are going to get this report. And here you can see that you are getting columns, beams, and other important points. So click on this columns, or directly you can go down here in the scroll down button is there, no? From starting to the last you can go there, right? On the right side I have showing you. So if you click on directly this one and move it bottom, here you can see now there is a small table available at the end. It is saying 14.9 cubic meter of concrete that is required. Total volume of concrete is what that is required, and the steel is 8 diabars of 4461 Newton, and 1551 of 10 dia, and 12 dia it is 6269. So total you are getting 12,281 meter
1281.
is the total quantity of steel in Newton. So if you want to convert that uh, uh, into kilonewtons, then it is, so if you want to convert that into kilonewtons, 12,281 divided by 1000, you will get 12.281 kilonewtons. So further, if you want to convert this into you want to convert into kgs. Further, if you want to convert into kgs, then what is the multiplication factor? It is going to be 1 not and 9.81. You have to multiply with 9.81 or 101.
సార్ స్టార్ట్ ప్రో స్క్రీన్ పోయింది సార్. స్క్రీన్ షేరింగ్ పోయింది సార్.
Yeah, 1 minute. now? Yeah, you
Yes,
can.
sir. It's coming.
So if you convert that into kgs, I'll show you here. We'll just type kilometer to kgs unit converter. Click on the unit converter and just click over here. So you can go to the mass kgs on newtons, right? Here, kilonewtons. We have what is our value? It is 12281. 12281, and to kgs, if you convert that into kgs, it is into 100. If you multiply that into 101, you multiply with 101, you will get this many kgs. And if you convert into tons by 1,000, you have to, sorry, it is 12.281, right? 12.281, then it is this. So total it is 1,200 1,252. So it is approximately 1.2 tons. You can say that 1.23 tons of steel is required. So this is the conclusion. So you need 1.23 tons of steel and volume of concrete 14.9 cubic meter of concrete. So with this, you can estimate the cost of the project. So you can take what is the cost of the project and you can design the entire structure, right? So with this, I'm going to stop over here and